Okay, so today we will learn the temporary tables in SQL Server. We'll be learning what the temporary tables are and types of temporary tables, local and global, and then difference between local and global temporary tables. Okay? So you can guess by the name that temporary table is it's a temporary table that exists temporarily on the database. So basically, as the definition says, the temporary tables are very similar to the permanent tables. Well, permanent tables are the ones that we have been using so far. Okay? And permanent tables get created in the database you specify and remain in the database permanently until you delete or drop them. On the other hand, temporary tables get created in the Temp DB and are automatically deleted when they are no longer used. Okay? And there's two types of temporary tables: local temporary table and then global temporary table. Okay? So now let's take a look at this temporary tables in action. So the first thing I want to tell you that when do we use temporary table? So basically, for example, now imagine we have a placeholder, or in other lessons that we learned about the buckets that we call the variables, right? Remember the variables? Variables were something that would store certain results inside it, and then that could be used further. So temporary tables are basically very similar to that. Like the concept is very similar to the variable concept. So now imagine you need to create a table and store some values in that table, but you don't want that table to exist forever. That's when you need the temporary tables. Okay. So I will first show you, and then you'll understand more how it works. So creating a temporary table is very easy, just like any other table. Creating any other table, you do the same thing. So temporary tables, and now to create a temporary table, you just say create table, and then you give a table name, temp table, for example. And the difference is when you give it a name, you have to put pound sign in front. See? Or hashtag, or whatever you call it. So this single pound sign, it tells the SQL Server that the table that you're creating here is a temporary table. Okay. If you remove this pound sign, this is just regular table, like permanent table. Okay. But if you put the pound sign, it's temporary table. And now let's create the temporary table. The rest is just like any other table. Only difference is in the name. You start the name with pound sign. Okay. The rest is the same with permanent tables. Let's create a temporary table, and say it would have ID, column, and then again name. Let's do it a varchar 20 again. Or actually, let's make it a student table. Okay, student name, ID, and then we'll call the temp table student. Okay, student name, student grade. Grade is ABC, so varchar, or actually, let's make it a char 1. So This means it will only accept one character. Okay. Then let's say major worker 20. Okay. Now let's create this table. Comma. Okay. Now we have this temporary table created. Okay. So to find the temporary table, the temp, even though if you look at this, we're using the homework database, right?
Yeah.
Ideally, it should have been created in our homework database, right?
Yeah.
If you're using the homework database, the table should have been created in the homework database. But if you take a look at it, we do not have this temp TBL student here. Okay.
Yeah.
That's because the temporary tables get created in TempDB. Okay.
Yeah.
Which is system database.
Yeah.
See, TempDB, this is it holds all the temporary tables. Okay.
Yeah.
And if you go there, and then if you go to temporary tables, now you can see our temporary table students. Okay. So, the reason is, like, if you take a look at it, we gave this name only, but the rest of the name, if we expand this and take a look, you see this this is auto generated. See, TBL student, and then all this underscore, and then 0008. This part is added by the SQL Server itself. Okay. That we'll talk about later, why that is there. But for now, we have temporary table that's called temp TBL student. Huh? So now let's select everything from this table. You would use this temporary table just like any other regular table. Okay, so I can say select star from this temporary table, and for now we don't have anything in that table. Okay. Let's insert some data into this table. Insert into and tell student values, say ID1, student name Anthony, student grade A, and major, say major is math. Okay. And then we'll insert a couple more. So 4, 5. And let's say this would be number 2. The name is Bonnie. The grade is B. Major is economics. And this would be number 3. Cindy. Grade is C. Major is, let's say, also mathematics. This would be number 4. Daniel. Grade is D. Major is psychology. I'm not sure if it's spelled correct, but that's okay. And 5. Let's see. Emma. Grade is E. And the major is biology. Okay?
Yeah.
Okay, so now we inserted data into this table. And this is what we have in this temporary table. Okay? Okay. Now, before I do something, I need to save this. Okay. Now look what happens. So now we have this temporary table, right?
Yeah.
And we have data in that table, and we can use this table any way we want. Okay?
Mm-hmm.
Now, first thing, let's try one thing. You see? Do you see what's happening? So this temporary table
Mm-hmm.
is called a local temporary table. Okay? The reason is this table can only be used within this instance.
Yeah.
Like if I select this here, it's working, right?
Mm-hmm.
And this is the one instance. But if I do the same thing here, it says it's an invalid object name temp student DB. I mean student TBL student. Okay?
Mm-hmm.
This
Yeah.
means this table, the temporary table, is only local to this instance only. This instance means only this window. Okay?
Yeah. Mm-hmm.
If I try to do the same thing for temporary table and select the from same temporary table in another query window, it does not recognize the table. Okay?
Yeah.
But for the other like permanent tables, it works fine, right? Like for example,
Yeah.
let's select all from salesman. Okay. As long as we have the database correct here, or we can provide the database name also here, like the three-part name. But the point is, this is working in this window, and also if I do the same here, this will work here also, right?
Yeah.
So basically, these permanent tables are recognized across any instances of SQL Server.
Yeah.
Okay,
Mm-hmm.
but the temporary tables are the opposite. They are only recognized within this specific instance of the SQL Server.
Mm-hmm.
This is recognized here, but if I do the same here, it's not recognized.
Mm-hmm.
That's because this table is a local temporary table. See?
Mm-hmm.
This one hashtag means it's a local temporary table.
Mm-hmm.
So that can only be referenced here only. Okay?
Oh, yeah.
In whichever instance that you create, that's only where it exists.
Yeah.
And now look at this now. So in our system database, right?
Mm-hmm.
We have this table, right?
Yeah.
And we created this table in this instance, right? Now let me close this. Okay?
Mm-hmm.
Now look, it's gone.
Oh, it's gone. Yeah.
You see, this temporary table, it exists until you close the instance that it was created.
Hmm.
Okay, so now this table is gone.
You mean the instance is
Window.
window. Yeah.
Yeah. This is one instance. Well, basically, the instance is actually this. For example, this SQL Server Management Studio that I opened is one instance.
Yeah.
Okay. But this one query window, it's well, in easy language, I can say it's a one query window. Okay.
Yeah.
Now let's create this table again. Okay.
Mm-hmm.
And then see it gets created, and then I can insert rows, and then again I can select, and it's all here. Okay.
Yeah.
And again, if I close this, It's already gone.
Mm.
This is because it's local temporary table.
Yeah.
Okay. Now let's create a global temporary table and see what happens. Okay.
Mm-hmm.
So to create the global temporary table, you put double pound signs.
Yeah.
Okay. So if it's £1, it's local. If it's double, then it's global.
Global.
Uh-huh.
Yeah.
Now let's create this. And let's insert data into this. Oh yeah,
Mm-hmm.
it's here. Now insert data. And now select the data. Okay.
Mm-hmm.
And now let's try doing it in another window. You see?
Yeah.
Now it's working in both windows.
Yeah.
Okay.
Mm-hmm. Yeah.
I can create another one. I can run another one. You see, because this is now it's not local, but it's global now.
Yeah.
So global means if a temporary table is global, it can be referenced or it can be accessed through all the instances of SQL Server.
Yeah.
Okay.
Mm-hmm.
Now, if I refresh this, we have this global temporary table now.
Mm-hmm.
Okay. And now, you see, now I'll tell you one thing, and then we'll come back to the naming of the local temporary tables. First, let me show you one thing. Okay, now we have this global temporary table, right?
Yeah.
And if you notice, when we close this window, right,
Yeah.
the temporary table was gone.
Yeah.
Okay?
Mm-hmm.
Yeah. If you see, this is the same thing for the global temporary table also.
Yeah.
And now if I execute this, it's gone.
Mm-hmm.
Okay? And now let me open that again and then show you one thing. So if I create this local temporary table, right?
Mm-hmm.
Let me create this local temporary table and then insert data into it and refresh. Now I have that temporary table, right? But as I said, the name is, it adds something at the end. The SQL Server adds something at the end, right?
Yeah.
This is because I can create the same named temporary table in another instance.
Mm-hmm.
You see?
Yeah.
Now we have the same table with the same name, and it's just in another instance. And I can actually insert the same data into it also.
Mm-hmm.
You see? Now if I insert this, it gets inserted. Okay? Now if I select everything from this table here, it shows me everything here. And the same table here, it shows me everything also here. And if I refresh this now, you see, now we have two temporary tables with the same name.
Yeah.
Okay? And that's why, so now the SQL Server shouldn't get confused. It will add this additions automatically so that our table names are always distinct.
Yeah.
Okay?
Mm-hmm.
Otherwise, if it doesn't add that, you can create the temporary table with the same name in as many instances you want, but then you cannot have same name table in one database at the same time, right? Then it would conflict with the SQL Server. That's why, to avoid that, SQL Server automatically generates this suffix for the table name, okay? You see, if you take a look at this, we created the table with the same name. But that is impossible, because if you now imagine, let me create this table in homework database, but not the temporary, but the real table. Okay.
Yeah.
So if I create this is going to happen in the homework database. So now I created the table in the homework database, right?
Yeah.
And if we take a look, if we look at the tables, now we have the table called TBL student here somewhere.
Yeah.
Let me see that. Refresh. Yeah, you see?
Mm-hmm.
And now let me create the same thing again. You see, it says the TBL student, there's already an object named TBL student in the database. So basically, you cannot have two objects, two tables with the same name in one database. Okay?
Yeah.
But since the temporary tables, whichever temporary table you create, it will only be created in the TempDB, this temporary database.
Mm-hmm.
It has to add these suffixes so that these table names are always unique.
Yeah.
Okay? Because you can create the same multiple temporary tables with same name.
Yeah.
And then they all go here. Now imagine if I could create the same with the two temporary tables with the same name, you would have two tables with the same name. And now imagine if one has different data than the other, then SQL Server wouldn't know which table to use.
Yeah.
Okay. So therefore, the SQL Server, to identify these tables for itself uniquely, it will add these suffixes at the end of the table name. Okay. See, it is 000B and 000C. That way, it identifies each table uniquely.
Yeah.
It works only for local temporary tables. You can create only the local temporary tables with the same name, but that is not the case for the global temporary tables.
Yeah.
Okay.
Mm-hmm.
Now let me create the global temporary table with like two global temporary tables with the same name. Okay.
Yeah.
Let's create this now. This time it gets created, and if we refresh, we have this temporary table. Now this is with the double hashtag. This is a global.
Yeah.
Okay. And now let me take this and try to create it in another instance. You see? Now it will throw an error. The reason is because a global temporary table is accessible from any instance of the SQL Server. Okay? I can access the same global temporary table from this window or from the other one. I can do the same. But it's not true for the local. That's why you can basically have multiple local temporary tables with the same name, because they can only exist in one window. Okay, you cannot access them in another window. So that's why it will not be you cannot get confused, because you cannot use it in the other window anyway. Okay.
Yeah.
So therefore, you can have multiple temporary tables with the same name. But that is not the case with the global, because global temporary tables can be accessed from any instance. So now imagine if you had this, let's imagine if the SQL Server let us create the global temporary table with the same name twice, just hypothetically imagine. Then what would happen? If I went here and then I selected everything from this global temporary table, and if I went here and I selected the everything from the same table again, but assuming it's the second table, now which should from which table should the SQL Server select the data? You see, it will get confused because you cannot have two identical tables in the same database.
Yeah.
Okay, so therefore, you cannot create the global temporary tables with the same name.
Yeah.
Okay. And if you look at this, the global temporary table name doesn't have this suffix.
Yeah.
Okay. Because SQL Server doesn't need to identify this table uniquely because there will always be one table with this name, one global temporary table. Okay.
Yeah.
Okay. Now, so I will put that here. Local temporary tables will disappear after the window is closed. Okay. And you can have multiple local temp tables with the same name. Okay. And for this one, I will put something else. Now we have two instances, right?
Yeah.
Let's imagine I'll put another one, and then I'll select everything from this global. Okay. Well, I guess we don't have anything in there. Now let's select. Okay, and then I will select everything from the same table again in the different window, and I'll do the same here also. Okay.
Yeah.
Now let's start closing these windows one by one and see which table disappears.
Yeah.
We'll close this window. So now if I refresh and see the temp tables, global is gone, and only one temp table is left. That is because it was created in this instance. Okay.
Yeah.
And if I close that also, and then refresh, now that is also gone. Okay. So, and now if I try to select, it says it doesn't exist. So basically, temporary tables, be it local or global, they will be dropped or deleted automatically once the instance that created them is closed.
Yeah.
Okay. Okay.
Or you cannot save them, yeah, like in
No.
a second.
No, because that's why it's called temporary table.
Temporary, yeah.
And you cannot save the temporary table permanent. Well, if you want to do that, you need to create normal
table.
Yeah. if you were able to save the temporary table as permanent, then it would lose its meaning, right?
Yeah, sure.
then it shouldn't be called a temporary table, right? Okay. So again, the purpose for these temporary tables is imagine, especially in store procedures, these temporary tables are used a lot in store procedures.
Yeah.
Let's say you need to create a store procedure that follows certain steps and logic to create a result, right?
Yeah.
For example, usually what happens is in one store procedure, imagine this store procedure should first select one data from one table and then join that with another table, and then combine that result of two tables, and then put that somewhere, and then go back and, let's say, select some other data from another table and put it somewhere else, and then join two results. Imagine. In this kind of cases, you use the temporary tables within the store procedures. So, for example, and then when you run the store procedure, each time you run it, it will create this temporary table. It will select the data and insert all that data into this temporary table.
Mm-hmm.
Then, now imagine we have this temporary table 1 that has data from 2 tables.
Yeah.
Now, let's say we have another 2 tables that we need to select the data from, and then combine the 2. So, and then the store procedure will join another 2 tables and combine the result and put it in another temp table, which is temp table 2. And then at the end, imagine now we need to join these 2 temp tables.
Yeah.
Okay. So then you will join these 2 temp tables, and then you will get the result. But then again, I don't want those results to be saved in my database permanently. I just want to see them, but once I'm done with them, they should disappear. They shouldn't take up my storage.
Yeah.
Right? So that is the purpose when you use the temporary tables. Temporary tables are like most of the time are used in multiple step store procedures that perform some step-by-step logic.
Mm-hmm.
And these are very useful in reporting services. Like if you are an SSRS developer or Tableau developer, those reporting guys, they use the temporary tables a lot. Okay? So basically now, let's close this also. Does the concept of temporary table make sense to you?
Yeah.
Okay, so for this global, also you cannot have multiple local temp global temp tables with the same name. Okay. Okay, now let's create this again.
Mm-hmm.
This is the local. So the difference between the local and the global is you first is in local you have 1 pound sign, and in global you have 2.
Yeah.
Then global temp table can be accessed from many other instances, whereas a local temporary table cannot be accessed from any other instance.
Yeah.
Okay. So now I have created this table. Let me insert data here, and then again select the data here.
Yeah.
Okay. And then now let's try to drop it. Delete temp table, and let's say drop, and then take this name, and then yeah, I'm missing drop. Oh, let's see. An object type temp table used in a create drop alter statement. Let's try drop table. Oh. And it's dropped. So basically, you can drop the temporary table earlier if you want to, just like you would drop any other table. Okay. But if you close the instance, it will be dropped automatically by itself. But if you need to drop it earlier than that, you can just drop it just like any other table. Okay.
Mm-hmm.
And now let's recreate this. This time let's do the global. Now insert stuff into it. Now select. And altering is the same thing, just like any other table. You say alter temp table. So let's say alter table, and then the table name, and alter column. Let's make the well, let's add column.
Mhm.
Add major date of birth. Let's say column date of birth, and it will be get date, and data type would be date time, and then default get date. Okay. So now the table is altered, and to see that we need to execute, and then you see now we have this new column called date of birth, and then if I insert one more row, yeah, I need to also provide the column names. Yeah, forget about it. I don't want to waste time on that. But basically, this is how you alter the table. Okay?
Yeah.
Just like any other table, you do the alter table command on the temp tables also.
Yeah.
Okay? So does it make sense so far, the concept of temporary tables?
Yeah. So why they use it? It's, you said like for reporting purposes, if to save storage.
Yeah, like you can, I mean, not necessarily only reporting, but mainly I have seen them in reports.
Yeah.
Like in reports, like the reporting people, they use long store procedures. Within those store procedures, they create this temporary tables on the way, and then insert data into this, let's say, temporary tables, and then use that data along the way within the same store procedure. Okay. Now let me show you one example. Maybe then it will be more clear. This is selecting into temp table. Okay. Now first let's check, do we have any temp tables? Refresh. Okay, we still have this temp table because we didn't close this. Okay, that's fine. We'll create another one. Let's say what we want to do is we want to select from the salesman table the salesmen that are from London, okay, and then save that result in one temporary table, and then select from that temporary table everything, okay, and then join that with customer table, okay.
Yeah.
And we will do that in one store procedure. Well, this steps might not make sense, but I'm just making it up so that you can see how you can use it in multiple step store procedures. But this steps, you would come up with these steps based on the requirement they are required, or the logic that you need to provide. Okay.
Yeah.
Like for example, if your boss comes and, hey, I need a store procedure that shows me all the salesmen that are from London, and then they make more than this commission, and then they are customers, and then so on and so on. So you think of that logic, and you put those in steps. You will create the steps to get to that end result.
Yeah.
And then you can just play with the store procedure and temp tables and everything, and put all those steps inside a store procedure. And when you run the store procedure, it will show you the end result. Okay?
Yeah.
Like you don't have to create this everything every time. So now let's say we will create a store procedure. Okay? Let's say store procedure, user store procedure. temp table example. Okay. And as and we don't need any, let's say, any parameters for this. As begin, and this is another way of creating this whole procedure, by the way. And let's say I want to select all from salesman where city equals to London, okay? And I want to select that into, okay, a temporary table. So I will say select all into temporary table temp, let's say temp salesman from salesman where city equals to London. Now let's try to execute this. You see?
Yeah.
Now what's happening is I'm just testing the data. See, now this temporary table holds the result.
Yeah.
Okay? Now basically I can use the same temporary table along the way with some other things. Now I have separate table. Now I don't need the salesman table. I separated the let's say salesman from London into one bucket. Okay.
Yeah.
I basically sorted out the salesman from London from this big salesman bucket, and I put that into temporary salesman bucket. Okay.
Yeah.
Now I can use that. I can make food out of it or whatever with along the way in the store procedure. So now let's say what else we can do, and then let's say also select all into, let's say temp customer from customer, okay, where customer where let's say city equals to London again. Okay.
Yeah.
And if I execute this one now, again 2 rows, and if I take this, select all from this temp table, now I have these 2 people. Okay. So now I have 2 separate tables, one with salesmen from London and another with customers from London.
Yeah.
Okay. Now I can do whatever I want to do with these 2 separate tables. Okay.
Yeah.
And I can maybe, let's say, next step, select all from temporary salesman as join, let's say, temporary customer C on S dot ID equals to C dot salesman ID. Okay. And then I can basically select S name, S city, C customer name, C city. Okay.
Yeah.
So if I now execute this, I will get this person. So there's only one person, salesman, whose name is Pete Alex from London that serves someone else. His name is Brad Guzman, and is also from London. So now you see what is happening here is if I create this procedure, this procedure will create these temporary tables all the time whenever I run it, okay?
Mm-hmm.
Now let's say I have this store procedure in my homework database, right?
Yeah.
Let's see this ability, store procedures, and the name was what was the name of the store procedure? USB temp table example. Yeah, this one, right? So now what I can do is if I close this, right?
Mm-hmm.
And if I refresh my temp DB,
Mm-hmm.
now my temp tables are gone, right?
Yeah.
If I using this, let's say homework DB, if I run that store procedure now,
Mm-hmm.
use the, or is that temp, use the, and what was the name of that store procedure? Use the temp table. You see, now what happened is I can only run this store procedure now,
Mm-hmm.
and it will create all these temp tables for me.
Yeah.
You see?
Mm-hmm.
Now I have these temp tables already created within the store procedure, and then I have this result. Basically, why is it useful in reports? This is like a very simple example that this even doesn't make sense, this result. But imagine now you have to create a report that has to uh, gather data from multiple tables and aggregate the data and then give you certain results, for example,
Mm-hmm.
right?
Yeah.
In that case, these temp tables will be very useful. Like just like we did just now, you can create one store procedure that would use multiple temp tables inside it, and you can basically make these steps within the store procedure. And every time you run that store procedure, it will go create those temp tables. It will basically follow your logic, all of the steps that you have told the store procedure to do. And
Mm-hmm.
it will return you like necessary results. Okay, this would even give you the result even though your table content has changed. Like for example, let's say one of those tables has more data now or less data. It would work accordingly. So you can keep inserting or deleting the data from your base tables, and this report would be changing accordingly.
Yeah.
Okay, so you can do whatever you want with these base tables, like salesman or customer, and then whenever you run this store procedure, it will follow this logic. Okay, it will say the logic it will always be, okay, I will take the salesman from London, I will take the salesman from, I mean, customers from London again, and then I will bring you those salesmen's name and city and the customer's name and city. And this logic, these steps will happen all the time whenever you run this store procedure, okay?
Mm-hmm.
Now imagine like you have a report that you have to prepare every month and see salesmen from London and their customers from London. You can create this store procedure, and then this will return you that result, and you can just give this result as a report.
Yeah.
Okay. But this is, as again, this is like a very simple example now. It doesn't even make that much of a sense. But in the real world, once you understand the requirement, like once you know what is being asked from you, you can create your own steps within a store procedure and then run that store procedure in your reports and get the results every time. And these temp tables are very useful in a sense that you can hold any result set temporarily for within this temp tables and use them along the way. Okay.
Yeah.
Okay, and then I want you to pay attention to this syntax also. This is something new that I want to tell you. It's called select into statement. This is kind of an extra thing. This is like off the topic, but still very useful thing. So basically, you can select any from any table, any data into any new table. Okay.
Yeah.
Okay. So now imagine I have this salesman table, right?
Yeah.
Basically, what I can do is, so in like usually what we do is we create a new table and then insert data into that table, right?
Yeah.
What you can also do is, if you want, for example, the salesman data or part of the salesman data in a new table, you don't have to go create the table first and then start inserting this data one by one. But what you can do is select any part of this data into a new table, and the table will get created on the fly. Okay. For example, what I can say is, now let's say select all from salesman where commission is higher than 15. Okay. So now this is what we have, this result. So the syntax is, you say, for example, this from part, but before that from part, you say select whatever you want to select into, let's say, commission table from salesman where this. Okay. Now what should happen is, if I execute that, this commission table gets created on the fly. Okay. And then it will have the data from this salesman table where the commission is greater than 15. Okay.
Oh.
You see, you don't have to create table commission and then give the column names and then insert into that table. You can simply say select whatever you want to select from whatever you want to select and then put that into a new table. You see? So now if I say select all from commission table, you see, I get that result, and I have a new table called commission now.
Yeah.
Okay. So this is called select into statement. You see, this commission table got created even though I didn't say create table anywhere.
Yeah, select into.
Yes. This is the syntax. Okay. So let me put that in a separate place as an extra thing. Select into. Okay. So this is select the data you want to insert, okay, and provide the name for the new table. This will be created on the fly, okay, and then this part is optional, but filter the data to be inserted. Okay, and this is optional. Now, like, imagine you don't want to filter the data. You want everything. You basically want to copy the table with the data in it, right? I can basically copy this table, saying select all into another table from salesman. That's all. And then it will take everything from the salesman table and put it into new table, which is a commission table. Okay?
Yeah.
This is the syntax for select into statement. Okay? And now there's another interesting thing about this one. Now let's say, let me show you one really quickly first select everything from the salesman table. Okay. Now, if you take a look, we have what, 11 rows, right?
Yeah.
And now I want to copy this table, right, with the data
Yeah.
into, say, salesman copy table. Okay. So I say again, select all from salesman. Okay. And then in between, I say into salesman copy. Okay.
Mm-hmm.
So if I run this, this gets executed, and now I basically, what I have here is I have the exact copy of the salesman table. You see, salesman copy.
Yeah.
Okay. If I select everything from this table, all from this table, and then I also select all from this table, this should be the exact copy of this table with the data. You see?
Yeah. Copy.
Yeah. So this is just a copy with the data also.
Mm.
Okay? So this is what you can use when you want to copy a table with the data also into another table. Okay? You just say select whatever you want to select, and then from this table, and then in between you put where to, okay, to like new table. And now imagine you don't want the data, but you only want to copy the structure of the table. Okay?
Yeah.
Now let's say I want to create a table that's called customer copy, but I don't want the data. I just want the structure. Okay?
Yeah.
So first let's select all from customer. Okay? To see what we have 8 rows, right? And we have customer ID, customer name, city, grade, salesman. Okay? And now I want to create another table that's called customer copy, but I don't want the data inside. I want it to be empty. Okay?
Yeah.
But I want the structure of the customer table. Like this customer table, let's see what we have. We have customer ID that's integer, customer name varchar, city varchar, grade integer, salesman ID integer, right?
Yeah.
So I want exact same table with the same structure, but I want to be empty. I only basically I only want the structure of the table.
Yeah.
Okay? For that, what you can do is you will basically say select all from customer, yeah, and you say into, and then you give the new table customer, say copy. Okay. But if I execute this, we will have the copy of the customer table, but we will also have the data, right?
Yeah.
Because this will select everything from the customer table, which is this 8 rows of data, into this table. So we will still have the data in this table, but I don't want the data. I only want the structure. For that, what I can do is I can provide where, in the where condition, something that is illogical, that doesn't make sense, okay? So I can say 1 equals to 2.
Yeah.
Okay? So what happens now is it selects everything from this customer table into this customer copy table where 1 equals to 2.
Yeah.
But this thing doesn't make sense, right? 1 cannot be equal to 2. That's why it will not find anything because this doesn't make sense, and it will only copy the structure of the table.
Yeah.
Okay? Because our condition doesn't make sense.
Yeah.
That's why it doesn't bring any data. Okay? If I select everything from this table, the customer copy table and the customer table, you will see the results. You see? Above I have the customer table, and below I have the customer copy table, but I don't have the data. I only have the structure of the table. You see?
Yeah.
And if I go here, refresh my tables, And then if I go to customer copy, this is the exact same thing. You see? This is the customer copy table with the customer ID, name, and all. And this is the customer table. You see? If you compare customer ID integer, this is integer, name varchar, and so on. But this table doesn't have any data, it's empty. And the customer table, it has the data. So this is how you copy only the structure of the table.
Yeah.
Okay? For example, if you have to create a similar table to what you already have, but you don't want the data, you just want the structure, you can create that table with this condition. Okay?
Yeah.
So I'll put here copy the table structure. Okay?
Yeah.
And no data. Okay, and this is the select into. This will select everything or certain things from a table to a new table. But in both cases, a new table will be created on the fly. Okay.
Yeah.
Does it make sense so far?
Yeah.
Okay. Good. Okay, this was something extra that you should know. Now let's go back to our slide. Okay, so this is we already know. So local temporary table and then a global temporary table. This is so the difference is the local temporary table exists only for the that instance which created it, and global temporary table, it can be accessed throughout any other instances. Okay.
Yeah.
Okay, and local temporary table is created. To see that, again, we go to the temp DB, which we already did, and so basically the temporary tables get created in the temp database. Okay, temp DB database.
Yeah.
So, and then, well, there is actually another way of seeing the tables within a database. For that, you say select name from tempdb, system objects, where name like something, whatever your table's name is. Okay? Or you can simply go to your Object Explorer and then take a look. And then, so basically, a local temporary table is available only for the connection that has created the table. See?
Yeah.
That also we already saw. So basically, if you close the connection or the instance, meaning in this particular query window, that temporary table will be gone. Okay? Yeah. And again, a local temporary table is automatically dropped when the connection that has created it is closed. The connection that created the temporary table, if you close that, the temporary table will be gone. That also, we also saw that. And if the user wants to explicitly drop the temporary table, you can use the drop temp table just like any other table. If you want to drop the temporary table before you close the connection, you can also do that by using the drop table. Okay?
Yeah.
Okay. And then if the temporary table is created inside the store procedure, it gets dropped automatically upon the completion of store procedure execution. Okay? So you see, we in our store procedure, we created the temporary table inside the store procedure.
Yeah.
So for that, if you run the store procedure, it will automatically get dropped. Okay?
Yeah.
It is also possible for different connections to create a local temporary table with the same name.
Yeah.
Okay? So we also saw that, like you can create the temporary table with the same name in different connections. And then SQL Server will add that suffix at the end so that it doesn't get confused. Okay? For example, user 1 and user 2 both can create a local temporary table with the same name, person details. So yeah. And now, global temporary tables. This is also we already saw with the two hashtags, and you do it with a create table, and then so on and so on. The difference is the global temporary tables are visible to all the connections of the SQL Server and are only destroyed when the last connection referencing the table is closed. Okay? For example, that global temporary table, if I am using that temporary table and someone else is accessing that same temporary table from another SQL Server, it will get dropped only after the last person closes their SQL Server. Okay?
Yeah.
Until that, it doesn't get dropped, because that also again makes sense, because if, let's say, I created the global temporary table and somebody else is using it, and now I close my window, and if it gets dropped, the other person who is using it will lose all of his data, right?
Oh, okay. Yeah.
So for that, it doesn't get dropped until the last person who is using it doesn't close the window.
Yeah.
Okay, so it will only get dropped when there is nobody accessing that global temporary table.
Yeah.
Okay.
Mm-hmm.
And then multiple users across multiple connections can have local temporary tables with the same name, but a global temporary table name has to be unique. And if you inspect the name of the global temp table in the Object Explorer, there will be no random numbers suffixed at the end of the table name. Okay?
Yeah.
We also saw that, like for the local temporary tables, at the end of the table name, there was this 0000B and then 0000C, right?
Yeah.
That is because you can create the local temporary table with the same name in multiple windows. And so that the SQL Server doesn't get confused, it will just add that suffix. But the global temporary table will not have that suffix, because you cannot have multiple global temporary tables with the same name.
Mm-hmm.
Does that make sense?
Yeah.
Okay. So now it's the difference. So the difference between the local and global temporary tables, I guess we'll be doing a recap. So local temp tables are prefixed with single pound. So when you create the local temp table, you start with a single pound sign.
Yeah.
Okay, with this single pound sign. Whereas global temp tables are prefixed with 2 pound signs, with this double pound sign. So that is how you know if it's a global or temporary, local temporary table.
Yeah.
And the second difference is the SQL Server appends some random numbers at the end of the local temp table name, where this is not done for global temp table names.
Yeah.
This is also, again, for local temp tables, SQL Server will add suffix, like it will append some random numbers so that it doesn't get confused. Okay?
Mm-hmm.
If somebody else creates another local temp table with the same name. But that is not true for the global temp table names, because they have to be unique all the time.
Yeah.
Okay. And the third difference is local temporary tables are only visible to that session of the SQL Server which has created it. Okay?
Mm-hmm.
So basically, the local temporary tables will disappear once you close the window that created it.
Mm-hmm. Yeah.
But whereas the global temporary tables are visible to all the SQL Server sessions. Okay?
Mm-hmm.
Basically, you can access the global temporary table with the other windows also.
Okay.
The fourth difference is local temporary tables are automatically dropped when the session that created the temporary table is closed. So basically, when you close the window that created the local temporary table, that temporary table will be dropped. So it will disappear. Whereas global temporary tables are destroyed or dropped when the last connection that is referencing the global temp table is closed. Like for example, say 2 or 3 people are accessing the same global temporary table, right? Like person A, person B, and person C, or all of them are using the same global temp table.
Yeah.
So that global temp table will exist until all of these 3 people close their windows.
Yeah.
Okay, so if person A closes the window and person B closes the window, and if person C is still using that temp table, so that temp table will not be dropped until that last person also closes it.
Oh, okay.
Okay, and that again, that logically makes sense because imagine if whoever created the global temp table closes their session, and then if that global temp table gets dropped, then what about the other 2 people who are using that? They will lose the data. So that doesn't make sense. That's why it will only get dropped when all of the people who are using it will come out of their sessions.
Mm-hmm. Yeah.
Okay.
Sure.
Good. Okay. So that was about temporary tables in SQL Server.
Mm-hmm.
Okay.
Yeah.
And okay. So in this session, we'll learn what the indexes are and why do we use the indexes and advantages of indexes.
Mm-hmm.
Okay. So why indexes? Basically, indexes are used by queries to find data from tables quickly. So that means when, for example, when you select everything from this, say, huge table that you have, let's say you have 100,000 rows of data in one table, right?
Mm-hmm.
When you select, say, everything from, or let's say select some filtered rows from that table, let's say within that 100,000 rows, let's say I want to see the index, the rows, if it's say a student information, all the students from say London, right?
Yeah.
So when you execute a SQL statement that says select star from table students where city equals to London, right?
Yeah.
So what happens is if you don't have the index, the SQL server starts scanning that table, like 100,000 rows, and scan that table and then filter only the students from London where city equals to London, and then return the results, right?
Yeah.
For that, it has to go through all of the rows, all the 100,000 rows,
Yeah.
to select the students from London.
Mm-hmm.
But when you create an index on that table, what happens is just imagine the index as the contents of the book, right? For example, you have this huge book, and you have to find one chapter from that book. What do? What you basically do is you go at the end of the book, and there's the contents, right?
Yeah.
And you look up on the contents, and you find that chapter, and then you find the page of that chapter, and then you directly open that page instead of scanning all, like going through all of the pages in that book, right? So this is basically how the indexes work. So just it's just like the book's contents. Okay.
Yeah.
So basically, what it says here is indexes are created on tables and views. Okay, so you can create an index on tables and views. Views we'll learn later. And index on a table or a view is very similar to an index that we find in a book.
Yeah.
Okay. So index in a book is basically the contents page of the book. Instead of going through all of the pages, you go to the contents, and then you find you locate that chapter in that contents page and find out which page that chapter is located, and then you go directly to that page, right? Instead of going through all of the pages. So when you create an index, on a table, you usually create the index. If it's a cluster index, you create it in one column. And what SQL Server does is it will create like behind the scenes, it will create just like a contents for that table. And whenever you filter the table, now instead of going through all of the rows, the SQL Server go directly to that index and then find that rows in that index and then go directly to those rows instead of scanning all of the rows. Basically, index will have pointers to the rows in the table.
Yeah.
Okay. So SQL Server goes first to the index. Now, since the index is only one column, it will be faster to find to scan one column instead of scanning all of the columns and 100,000 rows. And once it finds the filtered rows inside the index, it will just go to those rows directly. Okay?
Yeah.
And if you don't have an index and ask you to locate a specific chapter in the book, you will have to look at every page starting from the first page of the book, right? So on the other hand, if you have the index, you look up the page number of the chapter in the index and then directly go to that page number to locate the chapter. Obviously, the book index is helping to drastically reduce the time it takes to find the chapter, right? So in a similar way, table and view indexes can help the query to find data quickly. In fact, the existence of the right indexes can drastically improve the performance of the query. If there is no index to help the query, then the query engine checks every row in the table from the beginning to the end. This is called a table scan. So, and table scan is bad for the performance. If you don't have indexes in especially large tables, your performance will be very slow. Okay.
Yeah.
So this is the general concept behind the indexes.
Yeah.
So indexes will create contents page for the whole table. So let's say, well, in this example, this table doesn't have an index, and then to find all the employees who have salary greater than 5,000 and less than 7,000, the query engine has to check each and every row in the table, resulting in a table scan, which can adversely affect the performance, especially if the table is large. Since there is no index to help the query engine performs an entire table scan. Okay. So how do we create the index? We create the index just like we would create any other object in the SQL Server. You say create index, and then give a name. And if you take a look at the naming convention for indexes, they start with IX. Okay, just like stored procedures would start with SP, functions would start with FN, indexes start with IX. This is not compulsory. Like, you don't have to start with IX. You can give an index any name you want, but the best practices is you should start the index name with an IX, so that when people take a look at it, they understand that it's an index.
Yeah.
And then when you create an index, you say create index and then give the index name, and then you say on, give the table name that you want to create the index on, and then the column name on this table and this column. And then you can say ascending or descending. Okay?
Yeah.
So the index stores salary of each employee in the ascending order as shown below. The actual index may look significantly different. So basically, the first thing is that you cannot see the index content. Like, you cannot select rows from actual index. Okay, it's like you can only see that index exists, but you cannot actually see the contents of that index, because what happens is SQL Server generates some digital code for each row. wouldn't make sense for regular person. Okay. So now when the SQL Server has to execute the same query, it has an index on the salary column to help this query. Okay, so now that since it has an index on the salary column, when you say select the salary between 5,000 and 7,000, these are usually present at the bottom since the salaries are arranged in an ascending order, right? So now SQL Server will go directly to the bottom instead of starting from the beginning. Okay? And then SQL Server picks up the row addresses from the index and directly fetch the records from the table rather than scanning each row in the table. And now this is called an index seek. Okay? So this is opposite of table scan. In table scan, the SQL Server will scan all of the rows in the table. But when you have an index on that table and on a particular column, SQL Server will search through the index, not the table. It will not scan the whole table. It will only scan the index, and this is called an index seek. So it will basically search within the index. Okay. So now let's create an index, and so there's another concept called B tree. So it's basically a balance tree. I will try to show that in a in a drawing. But first, let's try creating an index. Okay. So now let's again select. Let me put indexes. Let's select all from salesman. Okay. Now we have this salesman table. Since it's very small. Okay. I want to show you one thing before we do that. There is something called execution plan in SQL Server. Okay. Execution plan is basically whenever you run any query on SQL Server tries to come up with the best way to perform that query. Okay. So and you can you can see the execution plan by clicking this button, include actual execution plan. Okay, or you can say estimated execution plan. Like if I do this and then I say include this, you see what it's happening is it goes from right to left. So when I'm saying select all from salesman, this is saying okay, it's called table scan. You see, it says table scan, and then the table name, which is salesman, and it's taking the 100% of the effort. Okay. So basically, what it's doing is it's scanning the salesman table 100%. And then it's selecting. This is costing like 0%. So all of the effort is going towards scanning the table. Once it's finding the rows, it's just selecting it. Selecting is not taking anything. If you look at this, so physical operation is table scan. So what is happening is it's doing a table scan. Logical operation is also table scan, and estimated execution mode is rows, and operator cost is this, and so on. You can see the statistics of the execution. Okay. And also the CPU cost, like 0.000, whatever that is the CPU cost. CPU is the processor. Okay. And so on. Estimated number of executions is 1. So this query will get executed only one time, since we executed it only one time. And then estimated number of rows is 11. So it's estimating that there will be 11 rows returned. Estimated row size is 41 bytes. Is it ordered? No, false, and node ID 0. And then you can also see the object, salesman, and output list is the ID, name, and then city, commission columns from the salesman table. Okay. Um, and then here, if you look at the select, its cache plan size is 16 KB, so it's caching it. So next time when you do the select start from salesman, it uses the same logic again. Okay. And now let's select all from salesman, but this time we'll filter. Okay. Where name equals to, say, M&M. Okay. Since this is a small table, it shouldn't change much. If we look at the estimated plan, it's scanning the table, and again, the same statistics. Okay. And if we look at the actual actual execution plan, it's the same.
Yeah.
Okay. And now let's create an index. So you see this execution plan, it will show you behind the scenes what the SQL Server is doing.
Yeah.
Okay. So it's showing that it's doing a table scan 100%. Okay. But let's try to create an index. But since this is a very small table, it might not even use the index. But let's try. Okay. So we'll create index, and we'll call it IX salesman name. Okay. So basically, when you create an index, you can create an index on the columns of the table. Okay.
Yeah.
And you choose those columns by, say, the filters that you think you might use in the future. For example, you have this huge table, and usually you use the filter on the name column of that table. Okay, like every time you want to select something from that table, you usually you filter by the name. Then you need to create an index on the name column, because you know that you have to filter by the name. So if you create the filter on the name column, now it can use the index on that column. Okay. And then I will say the table, so create index, and this is the index name. I started with the IX as the best practices, and then I'm saying on to specify on which table I want to create the index. So I'm creating the index on salesman table, and then on which column? I'm creating it on the name column, and then let's say I'll do ascending. So now ascending means like in an alphabetical order, right? So now this will create an index that will have the names in an ascending order. Okay.
Yeah.
So now we have the index created, and if we take a look at this table now, let's refresh this first, and let's take a look at the salesman table. And then if you look, there's a folder called indexes, and then if you see, our IX salesman name index is here. Okay. Okay. And now if I execute this, it's returning me this name. And now let's check the execution plan and see if it's actually using the index or not. Okay, it's not using the index now because this is a small table.
Yeah.
Okay, so since it's a small table, SQL Server is thinking, okay, it's okay to do the table scan.
Yeah.
Okay. But if it was like a big table, I don't know if we have a big table. Let's see this Adventure Works tables. Let's say dim account. And let's see if we have any indexes on this. Okay, we don't have. Okay, it has only 99 rows, so it's also a small table. I'm trying to find a table that has like at least 100,000 rows or something.
What is the minimum for index that rows should be?
There is no such thing as like minimum or maximum, but it's just the SQL Server will decide when it's trying to execute the query. It will decide, like, it will estimate.
Yeah.
You see, it's again based on the your like RAM capacity, like your memory capacity, or the SQL Server version and the power of the SQL Server that you have. Based on that, it will decide and it will estimate how much of resources it needs to use. And then based on that, it will choose either to use the table scan or the index. For example, say you have 100,000 rows in one table, and you see this display estimated execution plan, right? So this is the estimated execution plan, okay, for this select statement. Estimated means it's just estimating. SQL Server is estimating that, okay, if I do this, it will take me this this much time and this much effort, right? So when it estimates both, it estimates like table scan and it estimates the index. And sometimes, especially when the table is small, table scan could be faster, or let's say it could be less costly. Okay? In those cases, it will just pick and use the table scan. But if it estimates and the estimate comes up that index is faster in this particular case, then it will switch to index. Okay? So it will estimate it based on many factors. But the like it's like in general, if the table is big, that's when the SQL Server chooses to use the indexes. Okay. Let's see this table. I want to find a table that has. Okay, this is also 120. Like finance. Okay. Let's select all and see how many rows do we have. Okay, now we have 39,000 rows, right? In this table. Let's see. Fact finance. Let's see if this table has any indexes. Okay, it doesn't have indexes. Let's create an index on this table now. Okay. And first, let's take a look at the execution plan. So it's again doing the table scan, and this is what it's costing and all of that. So as of now, it's doing table scan because there is no index. Okay. Let's say from this where, let's see, what do we have here? So I want to filter date key. Okay, amount. Okay, let's first let's filter by the amount. Amount is, let's say, higher than 1,000. Okay, say 10,523. Okay. I'm trying to give it a hard time. Now let's execute this. So we have 9,000 some rows, and let's see the execution plan now. It's scanning again, and it's doing the filter. Now let's see, it's doing a table scan, and let's see the how much time it took. It's still taking 0 seconds, so we cannot really know like how much actual time it's taking. But let's try to remember this things like estimate operating cost is 0.222, I/O cost is 0.17, CPU cost is this. Okay, now let's try to create an index. Okay. Index ix amount on this table on amount column, and let's make it ascending. Okay. Okay. Now we should have the index. So we created this in the fact finance, and if we refresh, and okay, now we have the index. Okay.
Yeah.
Now let's see if it uses the index. Okay. It's again doing table scan. I guess it's not. Yeah, I guess this is not big enough for this data, or maybe it's using the cache. Let's do 10,200, so that it will not use the cache. Okay, it's still doing a table scan. I guess this is also not big enough for this. This data is not maybe big enough. And if you look at this, it's also saying missing index, impact this, create non-clustered index, name of missing index, okay, now let's, I didn't want to go for the non-clustered and clustered indexes for now, but just to, let's see, say, just to show you, I will try to create a non-clustered index, but I will explain what non-clustered index is in the next classes, okay?
Yeah.
For now, let's delete this index. Okay, so now we deleted this index amount non-clustered, okay? I think we need to use it here or here. I'm trying to find the place for this hint. Okay. Because it's here. Okay, I need to find the syntax for this. Just a second. Well, so just like usual, now you also have those files that interview questions. So also read those. Try reading the parts with about the indexes, since we started the indexes now, and also temporary tables, since we also learned those today. And continue doing the exercises just like usual. Okay. 15 each, and then oh, you were supposed to do some what was it, research and find out things that we didn't cover in the lesson, right?
Yeah, sure.
About function. Okay. Try to do that also for the next class. Basically, do not stop working on your skills. Okay? It's the class is only 2 hours. It's not enough for covering everything. So you have to also work on your skills by yourself. Also, do research, do exercise, at least read those interview questions. Like whenever you have free time, read about SQL. That's all you need to do. Okay. Okay. Good. Then I will send you this class scripts and also the presentations. And I will see you tomorrow.
Okay. Yeah. Thank you. See you tomorrow then.
Yeah. Thanks. See you tomorrow.